Okay, picking up where we left off, we're actually on page 16 now, talking about the programming process. The frame of mind you have to put yourself in to be able to write a program. So they talk about step one is to clearly visualize what the program does. Yeah, first of all, if you don't know what the heck your program's supposed to do, it'd be a tough thing to actually write an application to do that, right? You got to know what it is going to do. Visualize the program. Okay. I'd use design tools to create a model of the program. And in previous courses, you may have heard the word pseudocode, where you try to draft out exactly how this thing going to work, and just not really in a programming language, just in text. And then check for logical errors to make sure you're making sense. I mean, for example, don't calculate the guy's pay and then turn around and ask him what his hourly rate is. That would be dumb. Type the code and check for any syntax errors. Try to compile it, correct any errors, and repeat. Then run the application with different input to make sure that, if I'm asking for a payroll, I mean, if I put in 20 hours versus 40 hours, I expect the pay to be double, right? Correct any runtime errors, and then validate the results to make sure they work. So this is all part of software engineering, which is a big picture kind of a thing. Software engineering, there's an awful lot of tools out there that help you, like, test your application through this particular test environment. We're not actually going to be doing that, but yes, this test environment exists where you can develop basically an application that tests your application to make sure that every combination of input always works. So the next thing to talk about is a high-level philosophical thing, the object-oriented programming. Okay, so object-oriented programming, OOP. OOP is all about the concept of objects. So what the heck is an object? Well, okay. So an object is a way to bundle everything together. Let's say, for example, that I have an employee object. What that basically means is kind of bound to that employee is all of the things that you would need to know about an employee. Typically you need to know, like, what's his first name, his last name, and the employee's address and phone number, and what department they work for, and what their hourly rate is, right? Those kinds of things. So what they've done is he bundled it together so that all the employees have these attributes attached to them. But it's not just attributes, it's also actions. So anything that an employee can do, or I'm going to rephrase it, anything that you can do to an employee, you can hire one, or fire one, or promote one, or transfer one, those kinds of things. So calculating their pay, that would be a good thing that you could do to an employee object. So an employee basically has all sorts of attributes and all sorts of methods. Method is the actions. So attributes are nouns, name, address, phone number, right? And then actions are methods, then they're typically verbs, like calculate pay, those kinds of things. So attributes and methods. Cool. All right. So why am I bundling all this thing together? Well, it makes it so that once I got an employee thing put together, let's say I'm writing a payroll application. So I develop an employee object and it has all this stuff in it. And then the human resource people say, hey man, that's pretty cool. Can I borrow a chunk of your code? Well, if you do it correctly, all you have to do is just send them the employee object, because it contains everything you need to make an employee. So it makes code sharing really, really easy. Is that all you have to do is just pass them this one thing, and it automatically comes with all the attributes and all of the actions, which is pretty doggone cool. Okay, so there's a term for this where you break things into smaller chunks. It's called encapsulation. Encapsulation. So I have a complex thing in my head of all the things I want this application to do, but in order to work on it, I have to focus on one thing at a time, because my brain ain't big enough to be able to do everything simultaneously. So I want to break it up so that the employee object is the thing I'm thinking about. I do everything associated with the employee, and then I do everything associated with, whatever, doing a report. And then, then I stitch the two of them together. So encapsulation breaks large projects into smaller, manageable chunks. The catchphrase that I use to describe this is divide and conquer. And so you might think, well, why would I do that? Well, I already gave you one reason. One is easy code reuse. Okay? So somebody else wants to use your report generator that you created. Well, here it is. All right, cool. And the other one is it makes it easy to work in teams. Now, in a college environment, you're going to be running all this stuff by yourself, and so you're not really going to have a team. But in the real world, when you get a job, yeah, no one works by themselves. They're all going to be working in teams. And so the way it works is, okay, Sally, I want you to do this, and Bob, I want you to do that, and John, I want you to do that. And so each person is given an object to work on, and if they do it the right way, then when it comes time to stitch all the objects together, they all fit together. So it makes it so I'm trying to write a game, and I can hire more people and make the development of the game go faster through encapsulation. Okay, kind of makes sense? There's another term called abstraction. So abstraction is basically like this. Abstraction basically says, I don't really need to know how it works behind the scenes. Okay? Yes, I can calculate the employee's pay, but I don't really need to know how it works behind the scenes. I trust that this thing works, and so we're going to go on about it. So the catchphrase that I use to describe abstraction is, don't bother me with details. And so you get to choose how much of the guts of your application are visible to other people. So this sounds like I'm trying to keep secrets, right? That's what it sounds like. That's not at all. That's not at all what abstraction is all about. Abstraction means no one wants to see how it works behind the scenes. Let me give you an analogy that has nothing to do with programming. Let's say that you're a car manufacturer, and this guy comes up and he goes, hey man, I want to put a gauge on the car talking about to attach to the mass flow sensor to show the amount of air in cubic feet per minute that it's entering the engine. And the marketing people go, what? Why on earth would you want to put a gauge like that on the dashboard of a car? No one's going to know what that means. Yeah, but it'd be really cool to be able to see what's going on behind the scenes. See, it's not that the marketing people say, no, shh, we're going to keep that secret. That's not what they're saying. What they're saying is no one wants to see this. So no, we're not going to put a gauge on the dashboard attached to the mass flow sensor. That is just not going to happen. Not because we're trying to keep it secret. It's just that you, the owner of the car, don't want to see it. Well, that's what abstraction is all about. Sometimes you want to see what's happening behind the scenes, and sometimes you do not. That's what that's all about. We're going to be talking about all of these object-oriented things a lot in the next couple of chapters. So don't worry about too much. Okay, I'm kind of sort of done with the Chapter 1 thing, so let's just go back to NetBeans one more time. So this thing is called a project. The one we just did called a project. So what the heck is a project? Well, a project is basically just a bunch of folders, right? There's really not that much to it. So where are the files stored? Well, I kind of showed you that. If you go to your documents folder, there's one called NetBeans Projects. Then the name of the project, and there's a bunch of stuff in here. And so if I go to dist, this jar file, this is the bytecode that you could handle. You could copy this, put it on the thumb drive, and take it home, or take it to someone else and say, hey man, come look at my cool program. All right, that would work. The source is, of course, the Java file, which is just a text file, right? I mean, if I was to go here and say open with, and then pick Notepad, I'm not going to make that. I mean, it's just a text file, right? I mean, there's nothing special about this. Now, not so for the jar file. That is not a text file. Okay, so when we built this thing, we had some choices. So I'm going to pretend like we're going to build another one. So I'm going to do File, New Project, and here's all the choice of program types. So I'm going to suggest that we use this thing called Ant. Now, Maven, Gradle, and Ant are what's called build environments or build managers. And the concept is, if you have a very complex application that has lots of files, the machine has to figure out, okay, we need to build this piece first before we can build this one over here, because this one is dependent on that one. So it has to figure out the build order and put them all together. And it's got lots of things to do. Now, quite frankly, in our classwork, we're not going to be using any of those fancy features of any of the build managers. And so I just specifically said, just kind of randomly said, we're going to use Ant for our console application. Now, a little later on, we get to Chapter 12, we're going to switch over to using Maven. But right now, I went in here and said I want to do Java with Ant, and I just picked this plain old Java application as a template, a project template. And that built my project and put some code in there to give me a starting point. That's why I'm using Ant, because it works really well of giving you a starting point for a console application. Okay. So, here's a thing that I think is a little bizarre. Okay, now I'm just going to close out of this guy because I'm done with doing that, and so I go, oop. Well, it's, a week later I come back and I go, well, let me bring up NetBeans one more time. So I launch NetBeans, and what's going to happen is it's going to pick up exactly where I left off, and I quite frankly I find this rather strange. When you open up a Microsoft Word document, does it bring up the previous document that you were working on? How about Excel? No other application that I'm aware of that when you launch it, it automatically brings up the last thing you were doing. I think that's bizarre. Because after a while, imagine that. You're going to have 16 of these things, one for each chapter, plus, all your assignments. You can have 20 or 30 of these things. That's weird. So to stop that from happening, I'm going to do a right click on this guy, and I'm going to say I want to close this guy. And now if you do that, if you stop this guy and then, go back in, now it's not going to, remember, it's not going to show you all that stuff. Okay, so let's do that. And then I'm going to show you one more thing and we'll be done. Okay, so now how do I load that program now? Well, File, I want to open a project. And then I pick the thing I want. And I just picked the top part, okay? And it'll figure it out. So open project. Okay, so wait for it to come all the way up to the source. All right, so now let's pretend like I'm getting ready to submit this as part of an assignment in Microsoft Word. So the assignments are going to require you to copy and paste this stuff. Now I'm going to use keyboard shortcuts just because I like keyboard shortcuts. So I'm going to use Control-C. So what I did is I took my mouse and I lit up everything that's in the source thing. And I'll do Control-C. And then I'm going to fire up good old Microsoft Word. And fire me up a document. And then I'm just going to hit Control-V for paste. But see how I kind of spread everything out? I don't particularly like it. So I'm going to light up all this stuff. And then go right here where it talks about this little guy right here in paragraph, where it says remove space after paragraph. Doink. So now it's scrunched it up a bit, which is a heck of a lot better. Okay, is that making sense? Okay. There's a couple other things you need to be doing inside this, so I'm going to go ahead and show you one more thing. Is that later on we're going to be talking about how to make, we're going to be talking about the programming styles. This one's showing the curly braces on two separate lines. And so in the book and in lecture, I'm not going to do it that way. So I'm going to show you how you can fix that. Doggone it, we're coming up on the 15-minute mark. I'll show you that again in just a few.